Hello everyone and welcome to Mathematics Schooling. So in this video, we are actually going to revise the frequently used most important properties of conic section. Frequently used means these are the properties which we frequently use for framing very beautiful questions on conic section, and all these properties are really going to help you for your JEE Advanced test paper. So without any delay, let's start. So we are going to start with, first of all, the important properties of parabola, then I'll shift to ellipse and hyperbola. But ellipse and hyperbola have the same properties, so we are going to cover them together. Let's start with, first of all, parabola. The very first property, which is very important, is the reflection property of parabola. So what is that reflection property of parabola? Let us see. Reflection property says that, suppose you have a parabola. Okay, I'm going to make a parabola over here. The parabola can be any one. I'm just taking a standard parabola over here. This is the standard parabola. This is the focus. This is the directrix. So put of directrix, so I'm writing X. This is O. Standard parabola I have traced, but the property is true for any parabola, whether it is oblique or the standard one. What is the reflection property of parabola? I'm taking any arbitrary point P on the parabola. Then we know that for any parabola, PS is equals to PM. As you can see, PM is the perpendicular that I have dropped on the directrix. So we have PS is equals to PM. And at the point P, if you trace tangent lines, if you trace a tangent at the point P, if we trace a tangent at the point P and the normal at the point P, then the angle, this and this, will be theta. That means we are directly saying that tangent and normal at the point P are the angular bisectors of PS and PM. PS is the focal radius, PM the perpendicular dropped on the directrix. So at any point P on the parabola, if you trace tangent and normal, every time you are going to get the angular bisector of PS and PM. That is the reason we say that any ray which is originating from the focus and striking the parabola will become parallel to the axis of parabola after reflection. Will become parallel to axis of parabola after reflection. यानी अगर कोई भी ray parallel to axis आ रही है, तो after reflection it will be converging on the focus, right? This is the reflection property of parabola. कोई भी ray जो focus से आती है, after reflection will become parallel to the axis and the vice versa. So any ray coming parallel to the axis of the parabola, after striking the parabolic mirror, will converge on the focus. This is the reflection property of parabola that you need to remember. कैसे याद रखेंगे? इसका application usually इस तरह से होता है कि at any point P, the tangent and normal are the angular bisector of PS and PM. Okay, so this is the first property, which is the reflection property. It's very important. We use it for framing beautiful questions. Coming to the second property now. So again, for any parabola, the property is valid. What is that property? So in second property, actually, I'm going to club many results together. So just observe carefully what all things are there for any parabola. What are the important results that we can learn here? So just making a parabola, the standard one I have traced here with its directrix. Let this be the focus. This is foot of directrix X. Standard hai, so vertex is at the origin, obviously, right? Now what I'm going to do is, I'm going to trace a tangent line to the parabola. So I have traced a tangent at any point P. ठीक है, किसी point P पर हमने tangent को trace कर लिया है. So at any point P, we have traced a tangent line, which as you can see from the figure, intersecting the directrix, as well as it is also going to intersect the axis of the parabola. Okay? Chale, abhi we are going to name these points and then we are going to start with the results. I'm just assuming that this point of intersection is T. Let this point of intersection be D. And let this point of intersection P हमने ले लिया है, तो I'm going to take this as D, और ये जो y axis के साथ point of intersection है, इसे हम कुछ और ले लेते हैं. Let this point be L. Okay. Now what we are going to do? Any parabola, P is the point of contact. Tangent is drawn at the point P, intersecting the directrix at D and intersecting axis of the parabola at T. ठीक है. The first thing that we have to remember here is the portion DP. The portion DP always makes 90° at the focus. What we are learning here is portion of the tangent between the point of contact and directrix. It always makes 90° at the focus. So DP makes 90° at the focus. This is true for any kind of parabola, whatever it is. If it is standard, absolutely fine. Oblique hai to bhi result is valid. Okay? So P is any point on the parabola. PS is the focal radius. PD, we can say the portion of tangent between the point of contact P and the directrix. So DP is going to make 90° at the focus. From here, we can conclude that, यहाँ से क्या conclusion निकल सकता है कि if you drop a perpendicular from the point D, if you drop a perpendicular from the point D on the line PS, on this line PS, then foot of perpendicular is going to be focus. Foot of perpendicular will be focus. See, I'm going to extend it. ये जो PS line है इसे extend करते हैं, this will become focal chord. So the other end point, I'm just writing it as P dash. ठीक है? So P dash or PP dash is a focal chord. If you draw perpendicular from the point D on the focal chord PP dash, just observe it. You are dropping the perpendicular from the point D on the focal chord PP dash, then foot of perpendicular is always going to be the focus of the parabola. So this property is usually used for framing questions for getting the focus. अभी focus निकालने के लिए यानी क्या क्या information दिया जा सकता है? Maybe they will say that you have a parabola and you have the equation of PP dash. Further, the tangents at P and P dash intersect at D. Obviously, they are going to intersect at D because they are the ends of focal chord. Their point of intersection will be on the directrix, right? So PP dash पर जो tangents draw किए गए हैं, उनका point of intersection is given and the equation of PP dash is given. Now you need to get the locus of, or now you need to get the coordinates of focus of the parabola. अगर आपको coordinates of focus of the parabola चाहिए, in that case, what you are going to do, you are just going to take the foot of perpendicular from the point D on PP dash. So we can say that foot of perpendicular from D on PP dash is nothing but the focus of the parabola, right? This is nothing but the interpretation of the property that we are revising here. Which property we are revising? PD, the portion of tangent between the point of contact and the directrix, makes 90° at the focus. So this ultimately gives me that D से अगर आपने perpendicular focal chord पर drop किया, तो you are going to get the focus of the parabola, right? This is the focus of the parabola. अब इसी में हम आगे continue करते हैं. As I told you, we are going to cover many properties over here only. So next property पे अब मैं आती हूँ. The next property is point P, L, and T. Just observe these 3 points and remember that L is going to be the middle point of PT. You will get L as the middle point of PT. P point, standard parabola, so I can take 80 square to 80. We can write down the tangent at the point P. What is going to be the equation? Ty is equals to x plus 80 square. When you calculate the coordinates of the point T, it turns out to be y coordinate 0, x coordinate minus 80 square comma 0. Now you can yourself see that when you calculate PT का middle point, what you are getting is a point on y-axis. So L is nothing but the middle point of PT. इसे भी ध्यान रखेंगे क्योंकि कई बार हमारे पास questions में इस information की वजह से हम question में different thoughts या different ideas derive कर पाते हैं. ठीक है? तो simple सी चीज है. You just observe the figure carefully and see point P and T के लिए L is going to be the middle point. L will be the middle point, यानी L के coordinates भी मैं यहाँ लिखकर रख लेती हूँ. They are going to be 0, 18. ठीक है? आते हैं next point पर. Next point यानी इसी second highlight में I'm going to cover some very important more results. The next result that we are covering here is if you construct a circle with PP dash as diameter. If you construct a circle with PP dash as diameter, then that circle is going to touch the directrix. That circle is going to touch the directrix. So हमारे पास PP dash any focal chord of parabola को अगर diameter लेकर circle construct किया जाता है, then that circle will always touch directrix of the parabola. That will always touch directrix of the parabola. Further, if you draw tangents at P and P dash, then these two tangents will always be perpendicular to each other. The tangents drawn at the extremities of focal chord P and P dash will always be perpendicular to each other. This angle is going to be 90 every time. And the point of intersection will always be on the directrix of the parabola. So ये जो D point आएगा P and P dash के point of intersection, P and P dash के tangents के point of intersection D की अगर हम बात करते हैं, it is always going to lie on directrix of the parabola. ठीक है? इसी तरह अगर मैं एक और point लेती हूँ यहाँ पर, the next thing that I'm covering here is if I construct a circle with a PS as diameter. Now, what is this PS? PS is nothing but the focal radius. So हम लोग इसे इस तरह बोलते हैं कि if a circle is constructed with PS as diameter, तो ध्यान से देखेंगे, if a circle is constructed with PS as diameter, ये रहा PS, ठीक है, हम PS को diameter लेकर एक circle construct करेंगे, then that circle is going to touch tangent at the vertex. Then that circle will be touching tangent at the vertex. Then that circle is going to touch tangent at the vertex. ठीक है, तो अगर आपने पूरा फोकल कॉर्ड को डायमीटर लेकर सर्कल कंस्ट्रक्ट किया है, then that circle is going to touch directrix. While if you are talking about the circle which is constructed on focal radius as diameter, then it is going to touch tangent at the vertex. और एक और खास बात कि ये सर्कल टेंजेंट एट द वर्टेक्स को टच भी कहाँ करता है? एट द पॉइंट L. It touches tangent at the vertex at the point L. वो जो मिड पॉइंट आ रहा था ना PT का, at that point the circle is going to touch tangent at the vertex. ये सारी कैलकुलेशन हम करके देख सकते हैं, but right now we are just revising the properties which we need to learn, which we need to remember anytime when we are solving any question of parabola. ठीक है? So PS को diameter लिया, circle construct किया. The point to be observed here is it will be touching tangent at the vertex at the point L, which is nothing but the middle point of PT. ठीक है? अब फिर एक और रिजल्ट यहाँ से डिराइव हो जाता है. अब क्या रिजल्ट डिराइव हो रहा है? The next thing that we can derive here is, अब देखो, अब हम नेक्स्ट पॉइंट यहाँ पे क्या लिख सकते हैं? Because L is the point of contact of the circle with the PS as diameter, then definitely ये जो PS diameter है, it is going to make 90 degree at the point L. L is on the circumference of the circle, right? So PS is going to make 90 degree at the point L. And if it is making 90 degree at the point L, then what you can say is, देखो अब यहाँ से क्या इंटरप्रिटेशन आ रही है? यहाँ से इंटरप्रिटेशन सिंपली आ रही है कि if you drop a perpendicular from focus on any variable tangent, if you drop perpendicular from focus on any variable tangent to a parabola, if you drop a perpendicular from focus on any variable tangent to a parabola, then the foot of perpendicular L will always lie on tangent at the vertex. यानी बेसिकली ये कहा जाता है कि locus of, I'm just writing it over here, कि locus of foot of perpendicular dropped from focus on any variable tangent is tangent at the vertex. Is tangent at vertex. ठीक है, तो ये पैराबोला का रिजल्ट है कि आप उसके किसी भी वेरिएबल टेंजेंट पर अगर परपेंडिकुलर ड्रॉप करोगे तो the foot is going to lie, point L is going to lie on tangent at the vertex. वो हमेशा tangent at the vertex पर lie करता है. ठीक है, इसी के साथ एक चीज और मैं आपको यहाँ पे बताऊंगी. अब इसी सर्कल यानी इसी फिगर में तो मैं नहीं बताती, चलिए लेट अस ट्रेस इट वंस अगेन. तो हमारे पास एक पैराबोला, सपोज स्टैंडर्ड पैराबोला आई एम टेकिंग हियर वंस अगेन. ठीक है, at any point P and P dash you are tracing the tangents. कोई भी tangents हो सकते हैं, but because I traced the tangents at the extremities of focal chord in the previous case, तो हमने यही दोनों tangents वापस से बना लिए, P and P dash. ठीक है, so the chord is P dash. This chord is P dash. When you join them, they are going to intersect axis at the focus. That's why it is a focal chord. Further, I'm tracing its directrix as well. So हमने directrix भी बना लिया. This is the directrix of the parabola. Now, what I'm trying to say here is, or what I'm trying to add in the property is कि अगर आप let this point be, हमने इसे D ले रखा है तो D मैंने ले ली. If I join D with the middle point of P dash, if I join D with the middle point of P dash, then the line so constructed, यानी DM line में यहाँ पे बोल देती हूँ, but I think M हमने पहले ले रखा है. So I'll change that point. No, I have not taken any point as M. So this M is the middle point of PP dash. So if you construct or if you join D with the middle point of PP dash can be any chord, not necessarily focal chord. कोई भी chord हो सकती है. तो आपके पास any chord है. D is the point of intersection of tangents drawn at PP dash, which may or may not be on directrix. Directrix पे तभी आएगा जब आप focal chord लेंगे. So D is the point of intersection of tangents drawn at the extremity of any chord. So if you join D with M, the middle point of PP dash, then DM is always going to be parallel to axis of parabola. It will always be parallel to axis of the parabola. This is nothing but the diameter of the parabola corresponding to the chord PP dash having certain slope. ठीक है, तो ये भी पॉइंट आप ध्यान रखिए बिकॉज इस पर भी क्वेश्चन फ्रेम हो जाते हैं. किस तरह के क्वेश्चन फ्रेम हो जाते हैं? लेट मी गिव यू सम सिंपल एग्जांपल. Like sometimes what they do, they just say that you have a parabola touching the coordinate axes. You have a parabola touching the coordinate axes at some point A and B. A point is alpha comma 0 and the point B is 0 comma beta. And then you need the equation of directrix, or you need the coordinates of the focus, like that. All these information, the points that we have covered in the second graph, all these things will help us in getting the focus, the directrix, the axis of this parabola. First of all, let us see how I'm going to utilize this point for getting the slope of the directrix. देखो, एक चीज तो clear है कि the question is providing me perpendicular tangents to a parabola. यानी point of intersection origin जो होगा, that is going to lie on the directrix. So for writing down the equation of the directrix, I do have a point. But directrix लिखने के लिए you need slope of the directrix. And how you are going to get the slope of the directrix? So for that, what you can do is AB line likha. Just go to the middle point of AB. AB ka middle point will be alpha by 2 comma beta by 2. Now when I join the point of intersection of tangents at A and B, that is O, with the middle point of AB, that is M, then this OM is going to be parallel to axis of the parabola, right? It will be parallel to axis of parabola. And if it is parallel to axis of parabola, then this implies it will be perpendicular to directrix, right? It will be perpendicular to directrix implies कि अब आपके पास directrix का slope ready है. You can write down the slope of the directrix, the negative reciprocal of slope of OM. यानी अगर मैं लिखना चाहूँ तो equation directly लिखी जा सकती है. Passing through origin and having the slope. OM line का slope कितना आ रहा है? Beta by alpha. So I'll write it as minus alpha by beta into X. So here is the equation of the directrix, which is there for the given information for the parabola, right? So जो information हमें parabola के लिए दी गई थी, according to that, we have calculated the equation of directrix of the parabola. अब somebody says कि no, हमें तो focus भी चाहिए. So in that case, what you can do is, focus के लिए you just need to drop the perpendicular from O on this chord BA. Here BA should be a focal chord. तभी आपको foot of perpendicular focus मिलता है. तो अगर AB focal chord है, then point of intersection O, the point of intersection of tangents at A and B, that is from the point O. If you drop perpendicular on AB, then foot of perpendicular is nothing but the focus of parabola. तो आपको focus चाहिए, तो that is also very simple. You just drop perpendicular from origin on AB line. The foot of perpendicular will be focus. And once you get the focus, you can write down the equation of directrix as well. हमें axis of the parabola भी मिल जाएगा. Focus मिल गया, directrix मिल गया, parabola का axis you have. Now you need nothing else. Whatever they are going to frame, we will be able to handle the question perfectly. So देखो, second point में we have covered so many things and many results are like standard one and some are like the derived one. जितने results हम लिखेंगे सब kind of standard ये हमें याद रखने हैं. And properties से भी कुछ results जो derive हुए वो भी मैंने आपको यहाँ पर बता दिए हैं. तो ये रहा second point. जैसे आप वापस ध्यान से एक बार वापस से सुनिएगा because so many things I have given you in this second point. So आराम से वीडियो पॉज कर करके एक एक पॉइंट को समझते हुए ग्रास्प करते जाइए, एब्जॉर्ब करते जाइए. ठीक है, चलिए. Now we will be moving on to the next property of parabola. Let us come to the next property. So in the third point, now what I'm going to write, again I'll be tracing the parabola. See all these properties I am making you revise with the help of a parabola. Why? Because photogenic memory भी होता है. Parabola में कौन सा result हम लिख रहे हैं, अगर वो आपको अच्छे से याद रह गया through the figure, then you can write it for any parabola, right? So हम लोग क्या करने जा रहे हैं, ये रहा parabola. I'll be tracing two tangents to this parabola. So एक tangent ये रहा. The other tangent we are just considering this one. This is the second tangent that we have. Okay. I'm going to trace the directrix as well. So directrix of the parabola हमारे पास आ जाती है ये रही. ये directrix of the parabola है जो हमने trace कर दी. So for the standard parabola, this is the focus, this is the directrix, vertex. I'm writing these points as P, and this one is Q, and this is T. Okay, P, Q, and T. Tangents at P and Q are intersecting each other at T. Tangents at P and Q are intersecting each other at T, and S is the focus of the parabola. Now, the first result that we are learning here is just join P, T, and Q with the focus. Okay, आपको P, T, Q सबको focus से join करना है. और join करने के बाद the next thing that we have to do is mark these angles. These angles, alpha and beta, are equal. So what is the property? The property says that ST is the angular bisector of SP and SQ. Every time it will be the angular bisector of SP and SQ. Whatever the parabola is, अगर P and Q पर tangents को draw किया, if they are intersecting each other at T, then you are joining PQT with S, and now ST, the middle वाला line, ये जो line है, the one which is joining focus to the point of intersection of tangents, will be bisecting the angle PSQ, where P and Q are the 2 points of contact on the parabola. तो ये जो angle alpha आता है, ये जो angle beta है, they are going to be equal. ठीक है? Secondly, ST, जो middle वाला line आ रहा है, ST square will be SP multiplied by SQ. ये length की बात हो रही है यहाँ पर कि आपके पास middle वाली line ST का square will be SP into SQ. यानी basically I can say that SP, ST, SQ are in GP. तो हमारे पास PS, QS and TS lengths में भी एक relation होता है for any parabola. That relation is given by this one. ठीक है? Angle alpha और beta बराबर रहेंगे. ST square will be equals to SP into SQ. ठीक है? Along with this, there is one more result which is nothing but the, we can say, can be derived with the help of these two. वो क्या result है? कि starting from the focus S, you start moving in one direction and consider the triangle SPT. जैसे कि मैं clockwise direction में move कर रही हूँ, SPT and triangle STQ. Triangle SPT and STQ are similar. ये दोनों triangles similar आते हैं. तो any one direction आप पकड़ लीजिए और चलना शुरू करिए starting from the focus. So SPT and then you can say STQ. So direction हमने जो choose की वो STQ clockwise थी. आप चाहो तो anti clockwise करके भी properly दो triangles लिखो. Those two triangles are going to be similar. The important thing is ये दोनों याद रहते हैं तो automatically similar triangle का concept हम use कर पाएंगे whenever it is required. ठीक है? यानी हम उसे interpret कर पाएंगे whenever it is required. चलिए आ जाते हैं fourth property पर. The fourth property for the parabola that you need to revise, that you need to keep in mind, बड़ा simple सा property है. क्या property है कि for any parabola, किसी भी parabola की अगर आप बात करते हो and you are talking about its latest rectum, L dash I'm talking about, this is the focus. Then tangent and normal drawn at the extremities of latest rectum. Tangent and normal drawn at the extremities of latest rectum. So ये हमने tangents draw किए. And then we are tracing the normal at these points. Okay. Suppose their point of intersection, I'm just taking it as T and let this be N. तो आपके पास ये जो चार lines, चार yellow lines नजर आ रही है, these four lines are going to form a square. L, T, L dash, N is a square. Okay. For any parabola, tangents and normal at the extremities of latest rectum, they constitute a square. They always constitute a square where tangents का point of intersection T is nothing but the foot of directrix. This is going to be foot of directrix. ये foot of directrix आता है. L and L dash तो obviously latest rectum है. Extremities of latest rectum. Further, if we talk about N, तो N के लिए अगर मैं standard parabola ले रही हूँ तो N के coordinates हमें मिलते हैं 3a, 0. So basically I can say that the point of intersection of normals lie on axis of parabola at a distance of 3a, from the vertex of parabola. ठीक है? अब a, whatever the value of a is there for any parabola, accordingly you can get the point of intersection on axis of parabola. Tangents at extremities of latest rectum, हमेशा फुट ऑफ डायरेक्ट्रिक्स पर मीट करेंगी. Normals at the extremities of lattice rectum, they are going to meet on axis of the parabola at a distance 3a from vertex of the parabola. Vertex of the parabola से 3a distance पर ये point lie करेगा. And the most important thing, they are going to constitute a square. ये एक square बनाते हैं हमेशा. ठीक है, कोई भी parabola होगा ये result हमेशा square ही आएगा. चलिए, let us move on to the next property now. Coming to the next property that again you need to keep in mind. Again for any parabola, but I am tracing here the standard one. If you consider a focal chord, अगर आपने एक focal chord को consider किया, PP dash is a focal chord, S is the focus. So standard parabola के लिए focus is a, 0. Now SP and SP dash, these are called segments of focal chord. ठीक है, इसे हम क्या बोलते हैं? Segments of focal chord. These are called segments of focal chord. And when you take the harmonic mean of SP and SP dash, then you will be getting the length of half the length of lattice rectum. That is semi-lattice rectum. So we learn it like this. Half the length of lattice rectum kitna hoga for standard parabola? 2a. It is nothing but the harmonic mean of SP and SP dash. तो लिख लेते हैं. This will be twice of SP into SP dash whole divided by SP plus SP dash. ठीक है, तो ये आपको ध्यान रखना है. फॉर एनी पैराबोला द रिजल्ट इज वैलिड, कि किसी भी पॉइंट पर किसी भी फोकल कॉर्ड के सेगमेंट्स अगर हम एसपी एंड एसपी डैश लेते हैं, उनका हार्मोनिक मीन कैलकुलेट करते हैं, तो एवरी टाइम यू आर गोइंग टू गेट द लेंथ एज 2a. ओके, हार्मोनिक मीन विल बी 2a. फाइन. सो आई होप द पॉइंट इज क्लियर टू एवरीवन. लेट अस मूव ऑन टू द नेक्स्ट पॉइंट नाउ. चलिए देखते हैं अब हमारा नेक्स्ट पॉइंट, नेक्स्ट इंपॉर्टेंट प्रॉपर्टी रिलेटेड टू पैराबोला क्या है. Again, some properties I'll be clubbing here in the same parabola in the 6th point. So be careful, just stay observant and concentrate. So पहले मैंने एक standard parabola यहाँ पर trace कर लिया है. ठीक है, this is the standard parabola that we have. And for this parabola now I'll be tracing tangent lines. कुछ tangent lines हमने trace की, like one tangent line is over here. Then I'm tracing the second tangent line. Let this be the second tangent line. Okay, then I'm going to trace the third one. The third tangent line is this one. Okay, now I'm marking these points as PQR. इन्हें PQR लिखते हैं. PQR. ठीक है? PQR are the points on the parabola at which we have traced tangent lines, and as you can see from the figure, these tangent lines are actually making a triangle. ठीक है, एक triangle बन रहा है यहाँ पे, उसका नाम मैंने रख दिया ABC. So triangle is ABC. Now consider this triangle, the dotted one भी नहीं, मैं इसे shaded triangle बना देती हूँ. So ये हमारे पास एक shaded triangle ABC, which is framed by or which is formed by the tangents drawn to a parabola. तो एक parabola है, आपने उस पे 3 tangents draw किए. Now you're getting a triangle ABC. We will be writing certain results related to this triangle. सबसे पहले और सबसे important जो result है वो ये है कि if you construct the circumcircle of triangle ABC, यानी आप एक circle बनाइए जो ट्राइंगल ABC को सर्कमस्क्राइब करता है. ठीक है, द सर्कल सर्कमस्क्राइबिंग द ट्राइंगल ABC will always pass through the focus of parabola. ठीक है, आपके पास सर्कल ABC को सर्कमस्क्राइब करने वाला जो सर्कल होगा, it will always pass through focus of the parabola, and the result is true for any kind of parabola. आप स्टैंडर्ड पे जाते हैं या फिर ओब्लिक पैराबोला पर जाते हैं, every time the triangle constructed by the 3 tangents drawn to the parabola, if you consider its circumcircle, it will always pass through a fixed point, and that fixed point is going to be focus of the parabola. ठीक है, तो ये तो हो गया first point जो आपको ध्यान रखना है. Second point related to this triangle is कि अगर आप इसके ऑर्थो सेंटर की बात करते हैं, कि अगर मैं ऑर्थो सेंटर ऑफ ट्राइंगल ABC की बात करती हूँ, सो ऑर्थो सेंटर के कोऑर्डिनेट्स एज सच हमें स्टैंडर्ड पैराबोला के लिए याद कर सकते हैं, तो ठीक है, बट द इंपॉर्टेंट पॉइंट इज ऑर्थो सेंटर ऑफ ट्राइंगल ABC lies on डायरेक्ट्रिक्स. ठीक है, आपके पास ऑर्थो सेंटर जो होगा ऑफ दिस ट्राइंगल ABC वो हमेशा किस पर लाई करेगा, डायरेक्ट्रिक्स पर लाई कर रहा होगा. दैट्स व्हाई वी कैन से दैट इफ ऑर्थो सेंटर को हम h से रिप्रेजेंट कर रहे हैं, तो दैट इज गोइंग टू हैव द x कोऑर्डिनेट एज -a फॉर स्टैंडर्ड पैराबोला. अच्छा, फर्दर इफ यू टेक द पॉइंट p, q एंड r इज t1, t2 एंड t3. अगर आप t1, t2, t3 से ले लेते हो तो हम इसका y कोऑर्डिनेट भी लिख सकते हैं. y कोऑर्डिनेट में आपको रिवाइज करवा ही देती हूँ, बहुत सिंपल होता है. a टाइम्स सिग्मा t1 लिखना है, यानी जैसे कि सम ऑफ द रूट्स लिखा आपने t1, t2, t3 का, एंड देन प्रोडक्ट ऑफ द रूट्स लिख दिए, राइट. सो ऑर्थो सेंटर के कोऑर्डिनेट्स जो हैं दे आर -a, a टाइम्स t1 प्लस t2 प्लस t3 प्लस t1, t2, t3. ये है सेकेंड रिजल्ट रिलेटेड टू दिस ट्राइंगल एबीसी. पहला क्या था कि circle circumscribing the triangle ABC will always pass through focus of the parabola. The second one is, अगर हम ऑर्थो सेंटर की बात करें for the triangle ABC, it will always lie on directrix. ठीक है, and the coordinates मैंने आपको additionally बता दिए हैं. You can revise it, you can learn it. Another important result related to this triangle. अब अगला रिजल्ट इस ट्राइंगल से रिलेटेड क्या है वो देखो कि आपके पास है ट्राइंगल ABC, और इसी तरह नाउ आई एम गोइंग टू कंस्ट्रक्ट द ट्राइंगल PQR. एक ट्राइंगल PQR भी बना लेते हैं. कि PQR कौन सा ट्राइंगल है? दिस इज द ट्राइंगल व्हिच इज फॉर्म्ड बाय जॉइनिंग द पॉइंट्स ऑफ कांटेक्ट PQ एंड R. ठीक है, तो ये ट्राइंगल PQR और ट्राइंगल ABC को अगर मैं एरिया वाइज कंपेयर करती हूँ, यानी व्हाइट डॉटेड ट्राइंगल एंड ग्रीन शेडेड ट्राइंगल, व्हेन यू कंपेयर देम then you can write that triangle PQR का जो एरिया होगा that is going to be twice area of triangle ABC. ठीक है, 2 times PQR, sorry 2 times ABC is equals to the area of triangle PQR. यानी कौन से ट्राइंगल का एरिया is greater than the other triangle? The triangle which is formed by the points of contact. जो ट्राइंगल पैराबोला के अंदर आ रहा है वो बड़ा ट्राइंगल है. ठीक है, वही ट्राइंगल है जो पॉइंट्स ऑफ कांटेक्ट से बना हुआ ट्राइंगल है, और उसका एरिया डबल द एरिया ऑफ ट्राइंगल ABC आता है. IT has framed a direct question on this property. सो ये रिजल्ट आप डायरेक्टली याद ही रखेंगे. तो आपके पास एक ट्राइंगल है टेंजेंट से बनने वाला, और एक उन्हीं टेंजेंट्स के पॉइंट ऑफ कांटेक्ट से बनने वाला. द ट्राइंगल व्हिच इज फॉर्म्ड बाय जॉइनिंग द पॉइंट्स ऑफ कांटेक्ट is equals to 2 times the area of triangle formed by their tangents or formed by the corresponding tangents. ठीक है, तो regarding the triangle ABC, these are the 3 important things that you have to keep in mind. Let us come to another point. Now coming to the next point, the next point means 7th point. अब हम लोग इसमें लिखने जा रहे हैं. This point is also very important, and now this is about the normals. So देखते हैं क्या है हमारे पास normal से related result. Again, I'm just tracing a standard parabola over here. So ये रहा हमारा standard parabola. And first of all, we are going to talk about the conormal points. What are conormal points? I hope you all remember. Conormal points का मतलब क्या होता है? Suppose you have a point through which you have traced, or through which 3 normals are traced to the parabola. ठीक है, हमने एक point P assume कर लिया इससे, और P से हमने trace किए हैं 3 normals to the parabola. इस point का नाम A है, इसका नाम B रख दिया, इसका नाम C रख दिया. So we know that from a point P in the plane of the parabola, minimum 1 normal can always be traced and maximum 3 normals can be traced. तो जब आपने 3 normals trace किए, then you are getting 3 feet A, B and C. These A, B and C points are called conormal points, right? हम इन्हें conormal points बोलते हैं. These are conormal points, and specifically for standard parabola, if I assume the slopes of these 3 normals as m1, m2 and m3, then we have m1 plus m2 plus m3 equals to 0. ये standard result है for standard parabola. ठीक है, conormal points का definition valid for all the parabolas, but specifically if you're writing about the slope, then this result is true for standard parabola. And because of this result only, we can say that y coordinates, or we can write it like this, कि जो sum of ordinates होता है, sum of ordinates, that means y coordinates of ABC is equals to 0. ठीक है, आपके पास ABC के जो ordinates होंगे उनका sum भी हमेशा कितना आता है, 0 के बराबर आ जाता है. ठीक है, that sum is equals to 0. Y coordinate of A, B and C को जैसे ही आप ऐड करोगे, you are going to get the sum as 0. रीजन यही होता है because आपके पास m1 plus m2 plus m3 0 है, and y coordinates are like -2a m1 -2a m2 -2a m3. तो उनका sum जैसे ही आप लोगे, automatically it will become 0. The next thing related to conormal points that we have to remember here is कि अगर आप एक सर्कल कंस्ट्रक्ट करते हैं सर्कमस्क्राइबिंग द ट्राइंगल ABC, ठीक है, यहाँ पे ध्यान रखो ABC कोनॉर्मल पॉइंट्स है एंड वी आर टॉकिंग अबाउट दिस ग्रीन ट्राइंगल व्हिच इज फॉर्म्ड बाय जॉइनिंग द कोनॉर्मल पॉइंट्स। तो जैसे ही आप एक ट्राइंगल बनाते हो जॉइनिंग द कोनॉर्मल पॉइंट्स, then a circle circumscribing ABC. If we consider a circle circumscribing triangle ABC, then it will always pass through a fixed point. It will pass through a fixed point. What is that fixed point? Here the fixed point is going to be vertex of the parabola. ठीक है, ये दो सर्कल्स बहुत इंपॉर्टेंट है। कौन से दो सर्कल्स? एक सर्कल विच इज सर्कमस्क्राइबिंग द ट्राइंगल फॉर्म बाय कोनॉर्मल पॉइंट्स, कोनॉर्मल पॉइंट से बनने वाला ट्राइंगल का सर्कम सर्कल, that circle will always pass through a fixed point, the vertex of that parabola. This result is true for any parabola, whether standard or not. ठीक है, circle circumscribing the triangle ABC, which is formed by three conormal points ABC, will always pass through a fixed point. What is that fixed point? The vertex of the parabola. वो हमेशा vertex of the parabola से pass होगा। दूसरा ट्राइंगल, ये वाले ट्राइंगल की हम बात कर रहे हैं। The circle circumscribing the triangle ABC, which is formed by the tangents to a parabola, will always pass through a fixed point. What is that fixed point? So that fixed point is nothing but the focus of the parabola. ठीक है? So these are some of the important results which are frequently used for framing beautiful questions. All these results you have to keep in mind when you are dealing with the question of parabola. तो ये सारे IIT JEE एडवांस के लिए काफी important properties हैं जो हमने यहाँ पे रिवाइज किए। ठीक है, apart from this you can also revise the properties from the previous video that we have already uploaded under the series that mains PYQ, most important previous year's JEE mains questions. So under that you can go for that parabola wala video and can revise the properties related to tangent and normal. ये सारी properties tangent normal की ही थी, but how to write tangent and normal that we have revised in that video. मैं इसका link इस video में डाल दूंगी, please go through that video, बहुत जल्दी in short आप quickly उसको revise कर पाएंगे। ठीक है, चलिए, now we will be moving on to the properties of ellipse and hyperbola. So let us continue with ellipse and hyperbola now. अब ellipse and hyperbola काफी common properties share करते हैं, इसलिए we are going to read them in parallel. ठीक है, हम उसे parallel में read करेंगे। So let's start. First of all, ellipse and hyperbola के लिए मैंने sections यहाँ पे बना दिए हैं। क्या properties है? First of all, we are going to cover the common properties. After that, I'll tell you some very specific properties of hyperbola as well. चलिए start करते हैं। The first property is फर्स्ट प्रॉपर्टी की जहां तक हम बात करें, स्टार्ट करेंगे पहले एलिप्स से। द सेम प्रॉपर्टी इज आल्सो वैलिड फॉर हाइपरबोला। हम किस प्रॉपर्टी की बात कर रहे हैं, चलिए देखते हैं। तो एक एलिप्स मैंने ट्रेस किया, द रिजल्ट इज ट्रू फॉर एनी एलिप्स, बट आई हैव ट्रेस्ड अ स्टैंडर्ड वन ओवर हियर। ठीक है, अब इस पर एक टेंजेंट ड्रॉ करेंगे। लेट अस ट्रेस अ टेंजेंट लाइन, सो लेट दिस बी द टेंजेंट लाइन ओवर हियर। ओके, नेक्स्ट व्हाट यू हैव टू डू इज मार्क द फोकाई, जस्ट मार्क द फोकाई of the ellipse. हमने foci of the ellipse mark कर दिए, S1 and S2. तो ये रहे foci of the ellipse. किसी भी variable tangent पर if you drop perpendicular from foci of the ellipse, ठीक है, हमने perpendiculars drop किए from the foci S1 and S2. Let the foci, the foot of perpendicular be Y1 and Y2. ठीक है, इनका नाम Y1 Y2 हमने रख लिया है। तो what is the property? The property says that when you drop perpendicular from the two foci of the ellipse on any variable tangent, then अब दो results हैं जो आपको अच्छे से याद रखने हैं। The first thing, ये जो perpendiculars हैं, अगर मैं इनका length assume कर लेती हूँ P1 and P2, then first very important result is P1 P2 is equals to B square. ठीक है, जो P1 P2 आएगा that is going to be equals to B square. ये B square आता है, this is the first thing. Secondly, Y1 Y2, these points Y1 Y2, they lie on auxiliary circle. They lie on auxiliary circle of ellipse. यानी आपके पास ये जो Y1 Y2 points हैं, ये auxiliary circle of ellipse पर lie कर रहे हैं। ठीक है, so this is the first property which contains two things, कि अगर आपके पास कोई भी ellipse है, any ellipse can be there, you take any tangent to the ellipse, and now you are dropping the perpendiculars from the foci S1, S2. First of all, product of the perpendiculars will always be B square. And secondly, जो points y1 y2 हैं, they are going to lie on the auxiliary circle. They will be lying on the auxiliary circle. अभी जो first property है ना, p1 p2 equals to b square. Using this property and the reflection property, IIT Advanced has framed the question in 2022. So you can go and refer that question and then you can see that this property is really important. ठीक है, p1 p2 और है भी बहुत simple सी property. p1 p2 will be b square and secondly y1 y2 will lie on auxiliary circle. The same property is there for hyperbola as well. हमारे पास यही बिल्कुल same property होती है for the hyperbola. यानी suppose this is the hyperbola that we have, the standard one I have traced here. And now any variable tangent to the hyperbola. So trace any variable tangent. I'm tracing a tangent, just tracing a tangent to a hyperbola. Let this be the tangent. ठीक है, अब आपको क्या करना है, अब आपको perpendiculars drop करने हैं from the foci S1 and S2. जब आप S1 S2 से perpendiculars drop करते हो, जब S1 and S2 से perpendiculars drop किए जाएंगे, you will get the foot of perpendicular as y1 y2. Okay, you will be getting the foot of perpendicular as y1 y2. So I just dropped the perpendicular. ये रहे y1 y2 points. The foci are S1 and S2. The product P1 P2, which product P1 P2 we are talking about? These perpendiculars का product. So product P1 P2 is equals to b square and further y1 y2 lie on the auxiliary circle of hyperbola. ये जो y1 y2 points आएंगे ये auxiliary circle of hyperbola पर lie करते हैं. यानी देखो बिल्कुल similar property है. Ellipse में and hyperbola में we are writing down the same result. y1 y2 lie on auxiliary circle. ठीक है, चलिए now let us see what is the other common property of these two curves. So दूसरी common property पे अब हम लोग आते हैं. So partition continue रहेगा and we will be writing down now the second common property. That is the reflection property. Very important. We have the reflection property of ellipse and hyperbola and they are similar. क्या है reflection property? चलिए देखते हैं. पहले हम बात करेंगे ellipse की. ये रहा ellipse. एक standard ellipse मैंने trace कर दिया. Property is true for any ellipse. कोई भी ellipse होगा, the property is going to be valid. ठीक है, अब आप क्या करेंगे, फोकाई को ट्रेस कर लीजिए S1 and S2. P is any point on the ellipse at which I am tracing the tangent and the normal. ठीक है, हमने इसका एक tangent and normal ट्रेस कर लिया. Let this be the point P जहां पे हम tangent ट्रेस करेंगे and normal ट्रेस करेंगे. तो ये रहा tangent and normal. The point is P. Okay. Point P पर tangent normal trace करने के बाद now join the point P with S1 and S2. अब PS1 PS2 को join कर दो. We know that for ellipse PS1 plus PS2 is always 2a. ठीक है, ये reflection property नहीं है, ये तो additional मैंने ऐसे यहाँ पर लिख दिया है. PS1 plus PS2 is 2a. PS1 and PS2 are focal radii. अब यहाँ पर property क्या होती है? Property says that tangent drawn at point P, tangent and normal drawn at the point P are actually the angle bisector of PS1 and PS2. Point P को जैसे ही आपने foci S1 S2 से join किया, you are getting two lines segments PS1 and PS2. For these two line segments, tangent and normal at the point P act as the angular bisector. ठीक है, ये दोनों angle theta आते हैं. And that is the reason कि reflection property ये कहती है कि any ray originating from one focus after striking the ellipse at the point P will pass through another focus. कोई भी ray जो one focus से originate हो रही है, after reflecting from the surface of the ellipse will pass through the second focus. ठीक है, एक ray से originate होगी, second focus की तरफ चली जाएगी. इसका reason again वही है कि P point पर draw किया गया tangent and normal act as the angular bisector of PS1 and PS2. अब चाहे कोई भी ellipse हो, the result is going to be valid. ये है reflection property of ellipse. और यही reflection property hyperbola के लिए भी है. So let us write down that property. Let us see. This is the hyperbola that we have, standard one. Again, I'm tracing the standard hyperbola. So ये standard hyperbola हमने trace कर लिया. अभी आते हैं इसके एक tangent पर. So any tangent and normal at some point P I'm going to trace here. So tangent and normal हमने trace कर लिया. ठीक है, this point is P. So I'm marking this point as P and the foci as S1 and S2. ये S1 S2 आ गया. अभी आपको ज्वाइन करना है पॉइंट P को S1 से एंड S2 से, ठीक है. जस्ट ज्वाइन PS1 एंड PS2 and then you will notice once again that tangent and normal drawn at the point P are acting as the angular bisector of PS1 and PS2. वो फिर से आपके पास angular bisector of PS1 PS2 आता है, यानी ये रिजल्ट सेम है as that of the ellipse. जो ellipse में आया वही रिजल्ट hyperbola के लिए भी वैलिड होता है. And that is the reason, क्योंकि वो tangent and normal है at the point P. The tangent and normal at the point P are acting as angular bisector of PS1 and PS2. That is the reason कि कोई भी रे जो एक फोकस से ओरिजिनेट होगी आफ्टर रिफ्लेक्शन विल अपीयर टू कम फ्रॉम द सेकेंड फोकस, या फिर कहिए कि कोई भी रे विच इज एमिंग टूवर्ड्स द फर्स्ट फोकस, कोई भी रे जो फर्स्ट फोकस की तरफ आ रही है आफ्टर रिफ्लेक्टिंग फ्रॉम द सर्फेस ऑफ हाइपरबोला विल स्टार्ट मूविंग टूवर्ड्स द सेकेंड फोकस. एक फोकस से रे आएगी and after reflection it will appear as if it is coming from the second focus. या फिर आप इसे इस तरह कह रहे हैं कि कोई भी रे जो एक फोकस की तरफ मूव कर रही है after reflection from the surface of hyperbola will start moving towards the second focus. ठीक है, तो ये है रिफ्लेक्शन प्रॉपर्टी ऑफ हाइपरबोला. अच्छा, हाइपरबोला में भी अगर ऐसा ही हम रिजल्ट लिखें, इसे फोकल प्रॉपर्टी कहा जाता है. तो फॉर हाइपरबोला व्हाट डू वी हैव? PS1 minus PS2 is equals to 2a, right? So ये प्रॉपर्टी का रिफ्लेक्शन प्रॉपर्टी से सच कोई रिलेशन नहीं है, बट बिकॉज आई रोट इट फॉर इलिप्स, मैंने हाइपरबोला के लिए भी यहाँ पर रिवाइज करवा दिया है. बट बिकॉज बोथ ऑफ देम हैव द सेम काइंड ऑफ रिफ्लेक्शन प्रॉपर्टी, दैट्स व्हाई वी गेट अ वेरी ब्यूटीफुल रिजल्ट कंबाइनिंग दीज टू कर्व्स टुगेदर. क्या है वो रिजल्ट? अब वो मैं आपको दिखाती हूँ. कि सपोज वी आर टेकिंग स्टैंडर्ड इलिप्स एंड हाइपरबोला ही मैं यहाँ पर ट्रेस करूंगी. ये रहा इलिप्स, ठीक है, एंड ये रहा हाइपरबोला. Okay, ellipse and hyperbola having the same foci, S1 and S2. Okay. Now, if the two curves, ellipse and hyperbola are confocal, then they are going to intersect each other at 90 degree. ठीक है, इस पॉइंट का नाम मैंने फिर से P रखा. P is a point on ellipse. That is why P पॉइंट पे जब आप टेंजेंट एंड नॉर्मल को ट्रेस करोगे, so that tangent and normal is going to become the angular bisector of PS1, PS2, right? ये ellipse की प्रॉपर्टी, अभी मैं सिर्फ ellipse पे concentrate कर रही हूँ. P is a point on ellipse. Tangent and normal at the point P is going to be the angular bisector of PS1 and PS2. Correct? The same result is valid for hyperbola. P is a point which is also there on hyperbola, and that is why the tangent and normal at the point P to the hyperbola are going to be the angular bisector of PS1 and PS2. यानी सेम टू लाइंस PS1 PS2 के एंगुलर बाइसेक्टर्स ही हैं which are going to be the tangent and normal to the two curves. यानी आप देख सकते हो कि जो रेड लाइंस मैंने ट्रेस की है, it is tangent to one of the curve while normal to the other. अब tangent and normal to the other का मतलब क्या हुआ कि अगर मैं ये assume कर लूं कि this is the tangent line for ellipse and ये रहा tangent line to hyperbola, then angle of intersection between the two curves is going to be 90 degree, right? So what is the beautiful property that we have derived from the reflection property of the two curves is when ellipse and hyperbola are confocal, then this implies they will be orthogonal. Okay, and if they are orthogonal, standard curves हमें दिए गए होंगे. So if they have given us an orthogonal curves, that means if they are writing that ellipse and hyperbola are orthogonal, then this implies they are going to be confocal. So idea stream question on this concept as well. काफी ब्यूटीफुल प्रॉपर्टी है और इंपॉर्टेंट भी और इजी भी. दोनों का सेम रिफ्लेक्शन प्रॉपर्टी था जिससे ये रिजल्ट यहाँ पर डिराइव कर दिया गया है. ठीक है, चलिए, तो ये था सेकंड कॉमन प्रॉपर्टी बिटवीन इलिप्स एंड हाइपरबोला. लेट अस मूव ऑन टू द थर्ड कॉमन प्रॉपर्टी दैट इज देयर बिटवीन इलिप्स एंड हाइपरबोला. इलिप्स हाइपरबोला की नेक्स्ट प्रॉपर्टी पर चलते हैं. लेट्स सी व्हाट इज दैट. The third property that we are writing, which is common among these two curves, is the property that now I am writing is also there for the parabola. Parabola में भी same property होती है. अब क्या है वो property? Suppose I am tracing the standard ellipse. ये हम standard ellipse trace कर लेते हैं यहाँ पर. And then I am tracing a tangent line to this ellipse. ठीक है, हमने एक tangent draw किया. Let this be the tangent. I am also tracing the directrix of this ellipse. Directrices will be there. So both the directrices I have traced. Let the foci be S1 and S2. Now the property says that if P is the point of contact at which tangent is being drawn, and this tangent is intersecting the directrix at the point D, then PD is going to make 90 degree at the focus. यानी यही result parabola के लिए भी था कि portion of tangent between the point of contact and directrix subtends 90 degree at the focus. It is going to make 90 degree at the focus. Now the same result is there for hyperbola as well. यानी basically ये तो ऐसा property हो गया which is there for parabola, ellipse and hyperbola. तीनों के लिए valid है. तो ये रहा हमारा hyperbola. At any arbitrary point, I have traced a tangent line. ठीक है, ये रहा tangent line. Also tracing its directrices. So tracing the directrices. One directrix, the second directrix. ठीक है, तो दो directrices हमने trace कर ली. Point of contact is P, and point of intersection with directrix is D. Then the portion of tangent between the point of contact and directrix subtends 90 degree at the corresponding focus. Okay, it is going to make 90 degree at the corresponding focus. Corresponding focus का क्या मतलब हुआ? Tangent को देखो मैंने आगे extend कर दिया, and I'm just writing the other point as D dash. The focus is going to be S2. This is S1. So DP is making 90 degree at S1 and D dash P is going to make 90 degree at S2. The portion of tangent between the point of contact and directrix makes 90 degree at the corresponding focus. The result is valid for parabola, ellipse as well as hyperbola. ठीक है? So ये है कुछ common properties of the two curves. अब कुछ additional property मैं आपको hyperbola के लिए बताने जा रही हूँ, which are like very important and very frequently the questions are framed on that property as well. कौन सी property है वो? ये देख लेते हैं. अच्छा, उससे पहले ellipse की एक और property मैं आपको बता देती हूँ. The ellipse का next property is the property matches with the property of parabola. कौन सा property? कि suppose this is the ellipse and P is any point on the ellipse. Just join it with the focus PS and then construct a circle with PS as diameter. That means you are constructing a circle with the focal radius as diameter. So circle constructed with focal radius as diameter is always going to touch the auxiliary circle of ellipse. ठीक है, ये auxiliary circle of ellipse को touch करेगा. This property is similar to the property of parabola, where we have written that any circle constructed on focal radius as diameter will always touch tangent at the vertex. So parabola की जो property tangent at the vertex के लिए हमने लिखी है, वही property ellipse में auxiliary circle के साथ valid है. वही property ellipse में auxiliary circle के साथ आपको दिखेंगी. तो जो property tangent at the vertex के साथ हमने parabola में लिखी, same property with auxiliary circle you will find in ellipse and hyperbola. Hyperbola में भी same property आ जाएंगी. ठीक है, अब हम लिखेंगे कुछ additional properties of hyperbola. Only hyperbola की अब मैं बात कर रही हूँ. तो what are those additional properties जो important है? ठीक है, तो hyperbola की important properties में आते हैं first point पर. In the first point में we are taking any standard hyperbola में trace कर लेती हूँ. The result is valid for any hyperbola. I am just tracing a standard one. ठीक है, I am going to mark their asymptotes as well. इनके asymptotes भी बनाते हैं. चलिए, तो asymptotes हमने बना दिए, ये रहे asymptotes. So हमारे पास for the hyperbola, these are the two asymptotes. So these are the asymptotes that we have. Okay, now the next thing is for this hyperbola, suppose we are tracing a tangent line. I'm tracing a tangent line over here. Let this be the tangent. Okay, so asymptotes, who is the origin? Hyperbola हमने trace कर ही लिया है और हमने asymptotes भी trace कर लिए हैं. Let this point be P and they are intersecting the asymptotes at Q and R. ठीक है? Now you are getting a triangle OQR. Triangle OQR is there. Now, two things we are going to learn here. One, area of the triangle formed by the asymptotes and any variable tangent to a hyperbola. Area of triangle formed by the asymptotes and any variable tangent to a hyperbola is always a constant. And this area is always equals to AB. A and B क्या है? Length of transverse and conjugate axis का half. That means A is half the length of transverse axis. B is half the length of conjugate axis. अगर आपके पास वो दोनों लेंथ है, फिर hyperbola चाहे standard हो या oblique हो, in both the cases we are going to get the answer as AB. हमारा आंसर तैयार होगा, ठीक है ना? So first of all, what we are learning here, what we are revising here is area of triangle ORQ is always a constant and is equals to AB. And the second point that you have to remember here is P is going to be the middle point of QR. P is the middle point of QR. जो P point आएगा वो mid point of QR आता है, ठीक है? P is going to be the middle point of QR. So ये दो points हैं जो आपको याद रखने हैं for this hyperbola regarding this triangle OQR. चलिए कुछ और points भी लिखेंगे. Now coming to the next point. तो चलिए देखते हैं अब अगला point हमारा क्या है. So the next point is also related to the asymptotes and hyperbola. अब अगला point जो हम लोग लिखने जा रहे हैं उसमें again मैंने standard hyperbola ले लिया यहाँ पे. Let this be the standard hyperbola that we have. अभी हम इसके asymptotes भी draw करते हैं जरा. So let us trace the asymptotes. ये asymptotes आ गए इसके. Okay. Now, the next point that we are writing here is, you suppose you are taking a line which is perpendicular to transverse axis. Okay, I have traced a line perpendicular to transverse axis and intersecting these asymptotes and hyperbola at the points P, Q, R, S. So what we have written, any line perpendicular to transverse axis intersecting the asymptotes at PQ and the hyperbola at RS. Then the result says that अगर आप PR into PS product calculate करते हो, then this product is always going to be equals to B square. ठीक है, ये asymptote का result है कि आपने एक perpendicular line trace की है perpendicular to transverse axis. Intersection point with the hyperbola and asymptotes हमने लिख ही लिए हैं. P से लेकर R तक का distance, यानी देखो एक तो ये distance लिया गया, and secondly the distance that we are considering is from the point P till S. यानी एक point P पकड़ा and the second 2 points R and S are from the hyperbola. So PR into PS is always a constant and is equals to B square. इसे भी याद रखेंगे. अगला result again asymptote से ही related है. तो again मैं hyperbola trace करने जा रही हूँ यहाँ पर. So we have a standard hyperbola. Hyperbola can be any one. I am tracing the standard one. ठीक है, हमने standard hyperbola trace किया. उसके asymptotes भी trace करते हैं. चलिए, तो asymptotes हम trace करेंगे. So एक ये asymptote आ गया, and this be the second asymptote. Okay, hyperbola जरा हम तरीके से वापस बना देते हैं. थोड़ा सा और extend किया. Fine. So we have hyperbola and asymptotes. Now we have a line which is nothing but a kind of transversal. ठीक है, transversal line मैंने यहाँ पे trace कर दी. This is the transversal. See, it is not perpendicular to transverse axis. Not necessarily. ठीक है, and further it is intersecting. It is intersecting the asymptotes at P and P dash, while the hyperbola at Q and Q dash. तो कोई भी ट्रांसवर्सल दो जो asymptotes को PP dash and hyperbola को QQ dash पर intersect करेगा, उसके लिए we have few results. क्या result है? पहला result है that PQ will be equals to P dash Q dash. ठीक है, ये जो length आता है ना, ये जो intercept है between hyperbola and asymptote, ये दोनों length same आती है. PQ will be same as P dash Q dash. ये तो पहला result हो गया. And because first true है तो second one में you can write PQ dash, यानी अब आप कौन सी लेंथ ले रहे हो, P से लेकर आपने कंसिडर किया Q dash तक, will be same as P dash Q, यानी सेकेंड लेंथ हम लोग ले रहे हैं Q से लेकर पॉइंट P dash तक, राइट. सो हमारे पास सेकेंड जो रिजल्ट आ जाएगा, जो नेक्स्ट रिजल्ट हमारे पास बेसिकली आ रहा है, दैट इज PQ dash is equals to P dash Q. So ये भी इंपॉर्टेंट रिजल्ट है, ब्यूटीफुल क्वेश्चंस में काम आता है. हालांकि जेई एडवांस में मोस्टली दे स्टिक themselves around the reflection property, चाहे वो पैराबोला की हो या एलिप्स की हो या हाइपरबोला की हो, मोस्टली क्वेश्चन उसी के आसपास बनते हैं. But this property is also simple and can be used for framing beautiful questions. ठीक है, चलिए let us move on to the next property. अब अगली कुछ प्रॉपर्टी मैं आपको रेक्टेंगुलर हाइपरबोला के लिए बताऊंगी. सो रेक्टेंगुलर हाइपरबोला के लिए प्रॉपर्टी जो हम लोग लिखने जा रहे हैं वो क्या क्या है, चलिए देख लेते हैं. सो रेक्टेंगुलर hyperbola. The first result that we are going to consider here is suppose you have a rectangular hyperbola. ठीक है, कोई भी rectangular hyperbola, not necessarily the standard one. So I'm considering xy is equals to c square as the hyperbola. ठीक है, ये हमारे पास एक rectangular hyperbola है. अब the first result that we are going to learn, that we have to remember for the rectangular hyperbola is suppose you are taking 3 points on this and making a triangle. ठीक है, एक ट्राइंगल हमने बना लिया 3 पॉइंट्स एबीसी को लेकर. ओके, एबीसी को लेकर मैंने 3 पॉइंट्स यहाँ पर लिए और साथ में एक ट्राइंगल कंस्ट्रक्ट कर दिया. द फर्स्ट रिजल्ट दैट वी हैव टू रिमेंबर अबाउट दिस वन इज इफ एबीसी इज अ पॉइंट और एबीसी आर द वर्टिसेस ऑफ अ ट्राइंगल inscribed in a hyperbola. ABC are the points which are 3 points on the hyperbola xy equals to c square. That means rectangular hyperbola where you have taken 3 points. Then orthocenter of the triangle ABC is always going to lie on the same hyperbola. ठीक है, जो orthocenter होगा that is also going to be on the same hyperbola. यानी basically ये है कि if you take any 3 points on the rectangular hyperbola and construct a triangle, then its orthocenter will also be on the same hyperbola. ठीक है, this is a kind of standard result. Sometimes straightforward question ही frame कर देते हैं इस पे. तो आप इसे याद रखिए कि कोई भी 3 पॉइंट्स आपने उठाए on the rectangular hyperbola, making a triangle, then its orthocenter will always be on the rectangular hyperbola. आपके पास हमेशा जो पॉइंट आएगा, that orthocenter जो आएगा, that is always going to be on rectangular, on the same rectangular hyperbola. ठीक है, नेक्स्ट रिजल्ट है रिगार्डिंग द सर्कल एंड द रेक्टेंगुलर हाइपरबोला. चलिए देखते हैं क्या है वो रिजल्ट. अभी नेक्स्ट रिजल्ट के लिए हम लोग क्या करने जा रहे हैं कि फिर से मैंने एक स्टैंडर्ड हाइपरबोला को यहाँ पर ट्रेस कर दिया. रेक्टेंगुलर हाइपरबोला, व्हाट इज द सेंट्रिसिटी ऑफ रेक्टेंगुलर हाइपरबोला? √2, राइट? एवरी टाइम इट इज गोइंग टू बी √2. ठीक है, तो अब हम सेकंड रिजल्ट लिखने जा रहे हैं विच इज रिलेटेड टू द रेक्टेंगुलर हाइपरबोला एंड अ सर्कल. सो दिस इज द रेक्टेंगुलर हाइपरबोला. xy equals to c square I have taken, but the result is valid for x square minus y square equals to a square as well. Result क्या है? Suppose a circle is intersecting this rectangular hyperbola at 4 points A, B, C, D. Suppose a circle is intersecting the hyperbola at A, B, C and D. Then A, B, C, D के जो भी coordinates आएंगे, suppose they are x1, y1, x2, y2, x3, y3, x4, y4. ठीक है, यहाँ पे जो सर्कल मैंने लिया है इट इज नॉट नेसेसरली हैविंग द सेम सेंटर. यानी अगर मैं हाइपरबोला के सेंटर की बात करती हूँ तो ओरिजिन है, सर्कल का सेंटर कैन बी सम पॉइंट सी. ठीक है, सी डैश हम लिख लेते हैं. तो इट्स नॉट नेसेसरली कॉन्सेंट्रिक सर्कल. कॉन्सेंट्रिक है तब भी वैलिड होगा रिजल्ट, बट ये नेसेसरली कॉन्सेंट्रिक सर्कल नहीं है. सो द रिजल्ट दैट वी हैव टू रिमेंबर हियर इज कि आपके पास ए बी सी डी का सेंटर ऑफ मीन पोजीशन, यानी जैसे ही आप सिग्मा xi अपॉन 4 कैलकुलेट करोगे, दैट इज गोइंग टू बी द x कोऑर्डिनेट ऑफ मिड पॉइंट ऑफ OC डैश. ठीक है, यानी x1 प्लस x2 प्लस x3 प्लस x4 डिवाइडेड बाय 4 लिखने पर आपको OC डैश का मिडिल पॉइंट m मिल जाएगा. ठीक है, यही चीज y कोऑर्डिनेट के लिए भी है. सिग्मा yi अपॉन 4 आप लिखते हो तो यू विल गेट द y कोऑर्डिनेट, you will get the y coordinate of the midpoint of OC dash. ठीक है, so in case A, B, C, D are the 4 points of intersection of any circle and a rectangular hyperbola, then A, B, C, D का center of mean position is going to be the middle point of OC dash. अगर concentric circle आ गया तो middle point with the center coincide कर जाएगा, क्योंकि OC dash and M in that case they are going to कोइंसाइड, तीनों की तीनों कोइंसाइड कर जाएंगे, ठीक है. So this is the last property that we have revised for hyperbola. I hope you must have enjoyed all these properties and I hope कि सारी properties आपके लिए JEE Advanced में काफी useful भी रहेंगी, ठीक है. So if you like the video then please don't forget to like the video. अभी तक चैनल को सब्सक्राइब नहीं किया है तो please subscribe the channel and share this video with as many friends and fellow aspirants as possible. Thank you for watching. Bye bye for now.